All right, guys, let's talk about lesson 8, which is Lewis dot diagrams for covalent compounds. We have some rules that I want you to follow by. So when you're drawing Lewis dot diagrams for covalent compounds, first I want you to write the element symbols next to each other. If there are more than two symbols, then I want you to write the unique symbol in the center. What this means is basically the least electronegative, the one that's furthest left, not hydrogen, is going to go into the middle. Then the second thing you're going to do is you're going to count up the number of valence electrons for all the elements. Remember, we can use the periodic table to do that. Then you're going to put 8 electrons around the central atom, and if there's only 2 atoms present in the compound, then you're going to just pick one and place 8 electrons around them. Then what you're going to do is you're going to distribute the remaining valence electrons to the other atoms until you run out. So we want to make sure that we use all of the electrons that each element is bringing to the table. Then we're going to check to see if each atom has a complete valence shell, which is 8 electrons. Remember, hydrogen is the only one that will have 2. So let's look at this compound. This is diatomic chlorine. So if we were to count up the total number of valence electrons for the 2 chlorine atoms, each chlorine atom brings 7 electrons to the table. And since there's 2 of them, we're going to multiply it by 2. And so we have to place 14 electrons in this structure. So let's start adding them. We're going to start adding electrons. So 1, 2, 3, 4, 5, 6, 7, 8. So there's my 8 chlorine electrons around this one. And now this one does not have 8. So let's add the rest. If we take 14 minus 8, we have 6 left to place. So we're going to put 2 on top, 2 on the right, and then 2 on the bottom. So now the next thing we have to do is we have to double check to make sure that each atom has 8 electrons around it. But before we do this, I want you to call your attention to these 2 electrons right here in between the 2 chlorine atom symbols. Now remember, these are covalent bonds. They share their electrons. Remember, sharing is caring. So these 2 electrons belong to the chlorine on the left as well as the chlorine on the right. So now what we're going to do is we're going to count. So do all the chlorines on the left have 8? Yes, they do. And do all the chlorines on the right have 8? Yes, they do. So now that is stable. Let's look at hydrogen, dihydrogen monoxide, or you know it as water. So let's count up the total number of valence electrons that H2O is bringing to the table. So we have 2 hydrogens. Each are going to bring 1. So we're going to take 2 times 1 plus the 6 from oxygen. So that's going to give us a total of 8. Okay, so now since we have 8 electrons total that we are working with, we are going to place them in our Lewis dot diagram. Now remember, we have 3 atoms in this case, and oxygen is the one that is going to go in the middle because hydrogen can never go in the middle. So we're going to look like this. Now what we're going to do is we're going to place 8 electrons around the center. So 1, 2, 3, 4, 5, 6, 7, 8. Now we've placed all of our total valence electrons. We have 8 that we had to place. We've placed them all. So now what we're going to do is double check to make sure that everybody has a full octet. So oxygen does, check. Hydrogen does, because hydrogen is actually going to take these 2, and they are being shared, remember? So check. And then this hydrogen also has 2, so check. All right, let's look at another example, which is F2. Now, why am I going to show it to you this way? Because remember, the Lewis dot diagram for fluorine looks like this. 7 electrons here, 7 electrons around that fluorine. So when we count them up, we have 14 valence electrons that we have to place. So we're going to place 1, 2, 3, 4, 5, 6, 7, 8, and 1, 2, 3, 4, 5, 6. So 6 on this plus the 8 is 14. Now remember, these electrons are being shared between these 2 fluorine atoms. If you look over here, this fluorine atom was missing 1, and this fluorine atom was missing 1. So these 2 are going to be shared in the middle. So when we check to see if each has 8 valence electrons, yep, that fluorine has 8, and so does that one. And those 2 electrons in the middle are being shared. So now let's draw the Lewis dot diagram for hydrogen bromine. This is your hydrogen bromine. Hydrogen monobromide, if you want to call it. So we're going to pause the video. I want you to try this on your own, and then we're going to unpause when you're ready, and we're going to do this together. Great, well, welcome back. So let's see what you came up with. So we have to total up the number of valence electrons. So when we total this up, hydrogen brings 1 valence electron to the table, and bromine brings 7, so we have 8. So we're going to place them right next to each other with 8 electrons around bromine. Now we have to double check to make sure that each has the full octet. So bromine has 1, 2, 3, 4, 5, 6, 7, 8. So bromine is stable, and hydrogen has just the 2, so hydrogen is stable. Let's look at another one. So draw the Lewis-Dot diagram for CH4. I want you to pause the video, and I'll pause it when you're ready. All right, great. So when you draw it for CH4, carbon brings 4 electrons to the table, and hydrogen, there's 4 of them, each bringing 1. So that's also going to give us a total of 8. So carbon's going to go in the middle, and the 4 hydrogens are going to be around the outside. And we're going to have the 8 electrons in the middle in between the carbon and the hydrogens. Now when we check, carbon has 8 valence electrons around it, so it's stable, and each hydrogen has 2 electrons around it, so they're all stable. And that is what the Lewis-Dot diagram for carbon tetrahydride looks like. Now let's try it for Cl2. Pause your video and unpause it when you're ready. Great, well, welcome back. Chlorine has 7 valence electrons to bring to the table. Each of them is going to bring 7, so that's a total of 14. So when you draw it, it should look like 2 Cl's next to each other with 8 electrons around it. Now, what if all the atoms do not have full valence shells? Then you must add multiple bonds, so sharing 2 or more pairs of electrons. So that's what's going to happen in some of these examples. So let's look at CO2. When you draw CO2, you put your 8 valence electrons around your carbon in the middle, and then you are left with each oxygen will bring 6, so that's 12 plus the 4 from carbon, which is 8, which 6, 12 is 18. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. I'm sorry, 16 electrons. So if we look in this case, we are missing some electrons. Each element, the oxygens don't have 8 electrons around them. They only have 6. Carbon's okay. So what are we going to do? This is going to be a problem. Remember, these guys, these oxygens aren't stable. They don't have 8 valence electrons. So what we're going to do is we're going to have to share. So we're going to have to change the structure so that we can share electrons so that now we have multiple bonds. So this right here is going to be considered a double bond. And when we double count this, carbon still has 8 around it. And then each oxygen also has 8 around it. So they're also stable. Okay, so this would be a carbon in the center with a double bonded to an oxygen on the right, a double bonded oxygen on the left. So how many electrons can be shared? Well, if we're talking about a single bond, that will share 2 electrons. A double bond shares 2 pairs, or 4 electrons total, and a triple bond will share 3 pairs, which is 6 electrons. So HH bond is a single bond. An OO bond, or an O2 molecule, has a double bond in between it. And then a nitrogen compound has a triple bond beneath it, in between it. So let's draw the Lewis-Dot diagram for O2. If you were to draw it correctly, all right, you'd have to, each oxygen only brings 6 electrons to the table. So you're dealing with 12 electrons total. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. But here's the thing, you can't put 8 electrons around either oxygen first because neither oxygen will have a stable octet. So you're going to have to share. So you're going to have to put a double bond in between them. Now let's do the Lewis-Dot diagram for nitrogen, N2. I want you to work on this, and I am going to go over with this with you in class tomorrow. Now let's look at structural diagrams. In chemistry, a covalent bond is a pair of shared electrons is often drawn as a line. So when we do a 1 dashed line, that's called a single bond. So for carbon tetrachloride, this is what it would look like. This is the structural way to draw it instead of doing the dots. So there's two electrons, one shared pair between the carbon and the hydrogen. When we have two dashed lines, this is what we call a double bond. So for C2H2 or dicarbon tetrahydride, when you draw your Lewis dot diagram, you're going to have a double bond between the two carbons in order for everything to have 8 valence electrons around it. So since there are two lines, that means that there are 4 electrons or 2 pairs being shared between each carbon-carbon atom. Now when we're talking about 3 dashed lines, it's called a triple bond. So this is a triple bond, so that means that there are 6 electrons or 3 pairs of electrons being shared between each carbon-carbon atom. We're going to talk about this more in class. Hopefully this helps. Make sure you check your understanding and come to class tomorrow with questions.